Hello, hello. Shall I start? Sir, have a seat, please. Please, have your seat, yeah.
You mentioned about her also. Savitri, HOD, Mathematics, St. Xavier's College. Savitri.
माँ सरस्वती के श्री चरणों में वंदन करते हुए a lovely and warm morning to all of you. On behalf of the Institute of Science and Research, IPS Academy, Indore, I, Dr. Rusha Singh, is feeling happy to be given the chance to conduct the inaugural function of Professor Babulal Saraf Memorial National IPSA Science Exhibition and Science Show. In collaboration with Indian Association of Physics Teachers, IAPT, RC9, to celebrate the life and legacy of late Professor Babulal Saraf on his birth centenary year. He was the founder director of the Department of Physics in the year 2002. He has designed, developed, and fabricated several amazing experiments that deal with basic concepts of physics in the Department of Physics, ISR, IPS Academy, Indore. My hearty welcome to our guest of honor, Dr. Piyush Saxena, Sir, Head Project Coordination Cell and Laser Electronics Division, Raja Ramanna Center for Advanced Technology, RRCAT, Indore. Our judges of Science Exhibition, Dr. Anant Krishnan and Dr. S.K. Joshi, Mrs. Savitri, Head of the Department Mathematics, St. Xavier College, Aluve, Kerala, Dr. Injidisa from RRCAT, Dr. B.D. Shirvastava, President IAPT, Dr. P.K. Dubey, Executive Council Member of IAPT, our all esteemed guests present over here, HOD Physics and convener of the Science Convention and Science Show, Dr. Jiten Tripathi, all the HODs of the respective departments, our most valuable participants from different parts of the country, and students of IPS school and college. In the series of programs today, initially, we will have a science show, then the inaugural ceremony of the National IPSA Science Exhibition, followed by the science exhibition. Vidya Dhanam Sarva Dhanam Pradhanam. Knowledge is the best of all possessions. Experimenting is one of the chief ways of learning science principles and generalizations. Science shows are platforms that inspire innovation, creativity, and scientific temperament. The purpose of a science show is to stimulate interest in science and make students more observant and inquisitive. It's a dynamic process involving hands-on activities. It encourages students to explore and understand the world around them. This type of shows enhances creativity and critical thinking. It instills a sense of intrigue and enables students to develop understanding. Now this is the time for science show. It will be presented by Dr. Anant Krishnan, sitting on the dais. Let me begin by briefly introducing Dr. Anant Krishnan. He completed his MSc in 1967 and PhD in 1975 from Kerala University. He worked as a professor and head of the Department of Physics at St. Paul College, Cochin, till 2001, and visiting faculty at the International School of Photonics in QSAT, Cochin, till 2019. He has a total teaching experience of 56 years. He has more than 65 research publications of national and international repute. He was the convener of the National Competition of Innovative Experiment in Physics, NCIEP, and National Competition on Innovation in Computers for Physics, NCICP, conducted by IAPT for 10 years. He has performed more than 300 science shows in various renowned institutes in India. I welcome Dr. Anant Krishnan, sir, to present a science show. Sir, please.
Hello, good morning to all. Happy morning, and time for what is called physics stage show. Well, I retired in 2000 officially, but then onwards I was inspired by Professor Walter Levin. Have you heard about him? Not much. Please go to your Google and put Professor Walter Levin. A greatest physics show master in the world. He is also the professor of physics in MIT, America. Learning physics by sitting in the class, attending to lecturers one by one, writing down some abstract mathematics is really boring. Can there be a better way of imparting physics? Can there be a better way of learning physics? By enjoying it, just like a music. Can there be a better way of knowing the concepts in physics, which are the fundamental laws of nature? This was a dream of Professor Walter Levin, and he used to do physics shows. Inspired by him, I thought after retirement I will do that job. I started with few experimental demos, not exactly demos, you will find what it is. As I told you, enjoying physics. So that unknowingly you start learning physics. This is what I tried with a couple of experiments which I designed myself. But my stock of experiments has now increased to such large number that I can go on doing show for one day, which I am not going to do today. It was during that time that I came across Professor Saraf. I was there for a All India physics workshop for teachers done in Jaipur, CDBE. I was there for 5 weeks as a resource person. Professor A.W. Joshi was the convener. It was a dream of Khandelwal, the founder of IAPT, to have a workshop like that on experiments. So myself and Professor Khandelwal had a lot of correspondence. Those days were correspondence, no WhatsApp, whatever. So he asked for a financial support from central government. the grant came, everything started doing well. He was a very disciplined person. He used to write everything in a diary. And there he wrote down about conversations with Anant Krishnan on this All India workshop. But unfortunately, when it was about to materialize, Professor Gandelwal expired. And from his diary, A.W. Joshi knew about me and he wrote a letter to me to come as a resource person. There I had the opportunity to meet many young physicists who were doing a lot of experiments for 5 weeks. It was during that time that Professor Saraf was there all along. So some of the giants of physics, they were all in the guest house, my neighboring rooms. So Saraf and myself had very, very, very fruitful discussions. So we became friends. I never expected that in the latter years in my old age, I will have a chance to remember him and do some of my stage show items. So with humble respects, I dedicate today's workshop, today's physics stage show to that great professor of physics who gave a foundation of experimental nuclear physics in India. So my salutations to Professor Saraf. With these few words, we will start the stage show.
Put in your pockets.
Yeah? You can put it here? Okay, fine. Your name?
Ankit, sir.
Ankit. Now, the best friend here is Ankit because the success of this show, some peak points where you will enjoy, is in the hands of Ankit. Give him a good clap. For clapping your hands, showing your happiness, enjoyment, you should be lavish. When you clap your hand, several things happen. You may be sleepy because of the boredom of physics. When you clap, oh, something is happening. Oh, this is wonderful. He is talking about Professor Saraf. Again you clap. You can also clap, oh, it is really boring. Permission granted. We will start saluting our scientists who lived in the world. Big scientists. Remember about the name of big scientists like Einstein, Niels Bohr, C.V. Raman, Stephen Hawking. They are all going to come here to see you all now. But before that, I will put you in a trance, a meditation mood. Now, we are going to what is called my first program, Physics Meditation. Please close your eyes. I am the commander and you have to obey. Lights off. Lights off. Go inwards. Human mind is a potential weapon for discovering untold regions and vistas of our life. Yes, today is 24th January. After a great event in India, The baby Sri Ram is born yesterday in Ayodhya. Whole India celebrates. These gods, Sri Ram and so on, they were avatars. They were born in the world hundreds of years back. And also the avatars in physics were born several years back onwards. So also you, when were you born? Think about the time when were you born. The day when you were born. The day when you came to this universe. The stars in the sky, the planets, the whole cosmos with galaxies. You were born. You came to this world. Remember, then onwards you are growing fast. Think about your childhood friends, the best teacher you had, if you have any. And now you are studying in the +1, +2 or degree class. This great institution, IPS Academy, where a physics stage show is going on. You ask this question, who am I? I am a student here enjoying the beautiful Beethoven music, 11 o'clock in the IPS auditorium. What will you become after another 10 years? There will be at 25th January 2050. Where will you be? This is life. Time is clicking. Physicists should know more about time. We speak about space, a lot of things, equations of motion and so on, all mathematical equations. We learn a lot of physics. We are in space. We are also in time. Time is clicking. Nobody worries about it. Suddenly it will take you away behind the curtain. Think about those days. Now, this is life. Earth is a puny planet. In the whole cosmos, we don't know much about what is beyond Earth. Now, let us salute our scientists for the great discoveries and contributions they have done for science. Welcome to our scientists. Slowly open your eyes. Giants in physics. This is Aristotle, who lived years, centuries back. Sir Isaac Newton, come on, give a clap. The father of physics. Basic Pascal, the Pascal's law about transmission of pressure. James Joule. Robert Boyle. This light should be switched off. Fresnel, Maxwell's theories of electromagnetism, Ohm's law, Michael Faraday. We will see Faraday's experiment, Marconi, Hertz, Becquerel, radioactivity, Rutherford, the nucleus, Chadwick, the neutron, Röntgen, great discovery of X-rays. You can look into your body, bones. Niels Bohr, atomic model. Max Born, the couple of physics. Yeah, clap as ever, wherever you like. Enrico Fermi. earned first theorem in physics. Oh, we know him. Heisenberg, Pauli, the short fellow who was great theoretical SN boss. Music, continue. Music. So we are here. Scientists have gone through this time scale. You must become one of them in future. Now you are focused to these great gentlemen of physics. You are focused to what is going to happen. Your mind is well focused. Please keep your mind like that. Don't come out of it. Don't think about the cinemas. Don't think about your parents. Don't think about what to do after. This is the condition. I am conditioning your mind for seeing something about physics. And since we have done so much, I am going to start our program, physics program, with a prayer to Almighty. Because there is some power in the universe. We learn Newton's laws. We say F is equal to ma. We know what is momentum. We know angular momentum. We know torque. A lot of things. Why? When you say, why things fall down? You say, gravitation. Very good. Then your younger brother asks you, why is gravitation? Why that theory came? Things fall down. That is an observation. So if you go to the why of things, you will end up ultimately with the almighty power, some power in the universe. This power, whether you call it Sri Ram or Allah or Buddha or Christ, all are the same energy power which is within you. I am God. This God exists in you. It is the total integration of all such powers in the universe that I love to call God. And so the word Om means God is with me, within me. It is with this confidence that you should go forward in physics. So to that God, which is all pervading, everywhere, I give my salutations. That is our Gayatri mantra. So I will be chanting Gayatri mantra and doing a small interesting experiment. So to symbolize this great power, I am putting a symbol. You can imagine whatever it is a power in the universe. So the total power in the universe, if it looks like a Shivalinga, it is not intentional. It is the knowledge of tower. As physics people, we are calling knowledge of tower. And my mind, I am worshipping this power with an abhishekam. I am just pouring water on this great Lord. By pouring water, I am doing an abhishekam. So you are focusing here. It is interaction with the power of the universe, with myself, which is being poured. So it is lively interaction. And I am chanting this Om mantra. Actually, the mantra Om is Om Bhuvar Bhuvas Suvaha. Every part of the universe, the earth, Ubhaha, Bhuvaha, Bhuvaha, Bhur, Bhuvaha, Bhumi or earth, Bhur, Bhuvaha, then above that, Suvaha, the sky, the higher levels, go on to the cosmos. That is Om Bhuvar Bhuvas Suvaha. The rocket launching, it goes
into the space, to the cosmos, to the galaxies and far beyond. Tat Savitrvarenyam, all pervading, everywhere it is there. Bhargo Devasya Dhimi, if there is a God in it, Bhargo, His greatness, His power, Dhimahi, give me that power which is all pervading. So that is all idea about the Gayatri Mantra. We are not talking about any particular God. We are realizing our whole cosmos. As physics students, you should be able to know the whole galaxies and cosmos. So I will be chanting Om Bhuvar Bhuvas Suvaha Tat Savitrvarenyam Bhargo Devasya Dhimahi. Bhargo means the power. Bhargo Devasya. That God's power. Dhimahi. Give me. But I will be chanting only Om. And when I do this prayer, you will see a wonder happening. Let us see. Concentrate here. If possible, you can also chant along with me. Concentrate fully. Only when your concentration is perfect, things happen in physics also. So, Om Bhuvat Bhuvat Suvaha Tat Savitrvarenyam Bhargo Devasya Dhimahi Dhiyo Yonah Prachodayad. Om. Om. I have exhausted all my love, affection, dedication and inspiration to this Almighty, and my water jug is complete. I have given all to this great power in the universe. This is empty as you see. But the more I worship God, the more God blesses us with our own richness and knowledge. You saw my jar was completely empty. Still I love to worship the God. There is no water. Let me see. Om. 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 It goes on coming. Magic is happening. So the more you learn knowledge, the more knowledge comes into you and you become the source of knowledge. This is a great mystery. Let us see what happens. Om. 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 Empty. Whole thing gone. Now I am in evening of my life. All knowledge gone by physics stage shows. When the IPS people compelled me to come, I said I am not able to come, I am very old. They said, you come. You can do it. Can I do it? That's the question. Om. 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 Okay. Okay. We have done some physics also. You can do this. This is an ordinary jar. Whenever I do stage shows, I ask some of the audience to come and see what is happening. And whenever I call, you must come running. There should not be any persuasion. I have seen when I do stage shows in Punjab, if I say some students come and help me, once I was shocked because some 50 students are coming towards the stage. I said, no, only I want 2. That is their enthusiasm. When I am in Delhi, when I was telling the big audience, some of you come, well, definitely 10 or 12 comes. That was a funny thing. But by the time I reached Tamil Nadu and Andhra Pradesh, hardly 2 people will come. Students don't have that type of dynamism to jump into the pool. And in Kerala, which is my state, nobody will come. Some student come and help me, you see what is happening, nobody will come. I was feeling sad. This is the daring nature of students we want in physics, to try everything. And also I discovered one tragic thing. In Kerala, when nobody came, I was walking through the students. One student was saying, you go, you go. It should not. Can I have 2 students here? Come on. Yeah, good. That's a good number. Indore is not bad. Give a clap to these guys. So you are going to do this thing now. Come this side, one of you, and watch me what I am doing. They are witnessing with me. Could you see water in it?
Yes.
Could you see water in it?
Yes, sir.
Okay, they have seen water in the glass. Can you see a small hole at the bottom of the glass, steel glass inside?
Yes.
Yes, there is some water. Now, can you see a hole on the side of the outer glass vessel, steel vessel?
Yes.
There is a hole. Okay, now I am closing this hole outside the vessel with my hand. I have closed the outer vessel. There is a chamber between the outer vessel and the inner glass. So I have closed it. So whatever water is there in this glass will come. Come on, chant you both. Om, Om. Now the glass is empty. Is it empty? Yes. Is it empty? Yes, do you see something funny happening here inside? Have a look at it.
Yes. So water is coming.
Okay, tell them.
The water is coming. Water is coming from the jug to the from the hole. Water is coming.
Water is coming from the hole.
Yes, sir.
So there is an outer vessel and an inner vessel. The glass is stuck into it. You can do that. 2 holes, 1 hole. But the whole thing is full of water. When I close it, no more flow of water from the outer vessel to inner vessel.
Yeah.
Right? So you are going to hold it like this. Okay. It's a small hole. Audience will not see that. So you hold it. Close with your finger. Is there water?
Yes.
Pour it. Is it over? All water is over? Now what is happening? Remove your hand. Oh, water is coming. So this has to do with some idea which our Pascal had suggested years back. Pressure. You know, when you take a bottle and make a small hole and then close the bottle, water will not come out. Because there is only one hole through which water can come. And water is coming through the hole means there is a gap happening there. And air cannot enter. So this is what I am doing. I am blocking the air. So the pressure does not allow the vacuum-like thing is created, the water in the outer vessel to come into the inner vessel. It is blocked. So my inner vessel is full, outer vessel is there water. When I show it like this, all the water in the glass goes out. But now when I am talking blah blah to you, I am releasing my hand. So I am allowing air to come. What's your name?
Saurabh.
Which class you are?
11th.
11th. So
Shivam.
Shivam Mahadeva. Thank you very much. Give them a good clap.
Thank you, sir.
So we have learned something about pressure, water pressure. And this is one of the fundamental laws of physics. I think you have understood it. You will go to the market and purchase a steel jar and a steel cup. Now, you have learned something about physics. Now the question is, okay, let us celebrate a little bit. How many of you had your birthday in January already gone by now? Please stand up. How many of you had your birthday? 1, 2, 3. They come down. Also, who are celebrating birthday in January, please come down. Another 2 people. I want 6 people here. Girls are also allowed to come. I am going to give you balloon. This is the balloon for yourself. 1. Hold it with you. This is the balloon for you, birthday balloon. You have to give it to me back anyway. This is the birthday balloon for you. This is the birthday balloon for the remaining one. Where are the other 2 people? Birthday in this January? Nobody? So December over. Please stand up. Whose birthdays are over? December. I want 2 or 3 students more again to go. Anybody? Come on. These are balloons which you have to inflate. Enough. Come on, come on. Come on. They are going to celebrate their enough. My balloon stoke is exhaust. Okay. Now you all stand in a row here. You all stand in a row here. All of the audience must be able to see you. That's all. This is the row. Audience must be able to see you. Yeah, that's enough. Enough. Your place is right. Okay, fine. Very good. What's your name? Eh? Oh. This is Adharva Veda. Give a clap. Now your name? Yuvraj. Oh, nice names are there in Indore. Eh? Neha Geru. Beautiful name. Eh? Ritika. Rishika. Allowed? Oh, you must be able to allowed. Okay, fine. Say hello to all of them. Give them a good clap. Their birthdays are being celebrated. They are given an assignment. You have to fill up the balloon by blowing air from your mouth. And the balloons, when they are full, they will be big. They have to hold the balloon vertically up. You have to blow the balloon with air. Happy birthday balloon. This balloon will be inflated. Anyway, air pressure is there. I have been talking about it. You are learning about air pressure. And when it is full, you have to hold it like this. The balloon should stay like this vertically up. And whoever succeeds in doing it is the best balloon blower. Okay, your time starts now. Come on, give them a clap. No talking. No talking. She has found out there is a hole in the balloon. That is observation. Good. Good observation. So it won't be useful. These are all things which you should observe. Not simply saying, jump, I am jumping. Come on, clap. Who succeeds, show it up. Balloon should become full. Then close the mouth. Keep it, hold it vertically up when it is fully tight. Yeah, here is the prize winner. Next one, right? Next one, right? Who is doing it? Next one, right? No, it is not going up. Keep it. Happy birthday. Keep it like that. Yeah, next one. No. The principle of behind this is known as Bernoulli's principle. Okay? Bernoulli's principle. That is what is working here. How quickly you blow a balloon. You are not blowing. No. Keep the mouth very open. Because when air goes with high pressure through a big area, the inside pressure in the pathway decreases. And then the pressure decreases, more air goes in. It sucks all the air in the surroundings. Therefore, the balloon suddenly enlarges. This is the idea about Bernoulli's principle. You have done a good job, but you have got one more job. You have to exhaust the balloon, make it flat, pack it back so that we want to carry it back. Now the balloons under meter scale. Meter scale. To more make clear about this Bernoulli's principle, which the +1 students are learning, there is one more demonstration which I am going to do. Come on. There is the same thing. No air should be inside. See, all the air is thrown out. No, that's not the way. Air is there. Don't give me an air packet to carry from Indore. These are two balloons. Who is the last girl who went disappointed? Please come. One girl came and I said, you can go. Please come. Good, you also come on. You also come on. These are two balloons suspended. I am going to ask you to blow here. I am going to ask you to blow here. Will the balloons go away or attract? That is the question. Okay, you got a problem? Two balloons are... Okay. When I blow air here, normally you will expect the balloons to go separate. Repulsion. You have heard about repulsion in magnetism and so on. But actually what will happen is, when you blow here, they will attract. This is what we are going to try. Stand here normally, and when it stands still, your mouth should be exactly at this level, and let it stop and blow, and let us see what happens. Try. Try blowing. Try blowing. Blow powerfully. Now it got stuck. You can wait for a while, the balloons are stopping and so on. Okay? It is already hanging, probably some AC vent is there pushing air, etc. But what's your name? Yeah, short name only, madam. Sangeeta. Sangeeta is music. Now you have to bend down a little bit. Air has to come like this. So bend down, bend down. You are blowing on the balloon. That is the problem. You have to blow air in the gap. I will do one thing. I will increase the gap a little bit. That's it. It's succeeding. You try. Yeah. Good. Good. It's a good trial you did. So please go in. So whenever, get me that flying disc. So when you can try this at home, two balloons, air blowing. So this is happening. Whenever there is a flow, this is happening. See, you have got your blood vessels. Blood is flowing through the vessels. Blood is flowing with a velocity, right? Blood is flowing with a velocity. Water is flowing with a velocity. You have got a water hose, and when the water hose is there, you press the mouth of the water hose, you will see water coming with a greater pressure. If you want water with a greater pressure, squeeze a little bit, narrower hole, velocity increases. You get a point? Did you understand? So, when you are gardening, if water pressure is less, the tip of the tube you press with your hand a little, squeeze a little, area decreased. So similarly, when blood flows, blood clots form. Here and there, blood clots form. And at the blood clot area, the area of cross section is less. Are you following? And when it is less area, velocity increases. Higher velocity. When with higher velocity blood flows, pressure decreases. So suddenly your blood vessel sticks together. No more blood to the heart. The heart begins jumping and you die within 1 hour. This 1 hour is called a golden hour. By the time if you are able to reach the hospital, they will give you an injection called thrombosis. That injection will dilute your blood. So when it is diluted, what happens is some clot changes position and suddenly there is a small gap through which blood again begins to flow. So you are saved for the time being. So a heart attack is a beautiful example of a flying disc. Flying disc. इसके अंदर नहीं छोड़ो. So you got the idea about Bernoulli's principle. I had a flying disk. I have not carried it. When you take a flying disk and throw, what happens is the air flows through the upside of the flying disk and the lower side of the flying disk. Right? So a flying disk is something like a vessel like this. Something like this. Flying disk. So when air flows on the top, its velocity will be more. At the bottom, velocity will be less. When velocity is less, pressure is applied, and that is what keeps the flying disk moving. Okay, anyway, I'm not explaining too much about it. So we have learned something about pressure. How come this atmospheric pressure? Atmospheric pressure is because Earth has got an atmosphere. How much height? About 200 meters. Air is there. This air, because of gravitation, is pushing the Earth. Okay? So, for example, I am going to show you an interesting demonstration based on this idea of atmospheric pressure. I will try to go a little quickly, gradually, because you are understanding. Okay. There is a sheet in my stock which I have here. Okay. And this is a sheet, special material. Can any two girls come here? You can see at a close quarters what is happening. Two girls, please come. Because you get the pleasure of doing an experiment with me. You stand near me. And one more? Yeah. Yeah. This is a special material. Can you see this? It's a special material. It's a rubber sheet without any corrugation. This rubber sheet has no corrugation. You can't purchase a rubber sheet from the shop without any corrugation. Absolutely plain. If you purchase a shoes, they would have purposely cut some lines and so on. They want it to be not smooth. If your shoes is perfectly smooth, once you put your leg there, you cannot take it out. So, vacuum comes there. This is a perfectly smooth rubber sheet, which I have put on a glass sheet. That's it. Now, I want to pull it up. So, I can't touch it like that. So, I am putting something like a catch I want here. So, okay. Now, what happens? Atmospheric pressure is there. The pressure is acting on the rubber flat. Okay? How much atmosphere? 76 centimeter of mercury equivalent to. The pressure is 76 centimeter of mercury or 200 meters plus of our air column. Pressure formula is H rho G. I think you know that. HdG is the pressure, H rho G. So height of atmosphere is around 200 meters or more because the density goes on decreasing. Density of mercury is 76. Okay, fine. So otherwise, density of atmosphere into G. G is acceleration due to gravity. All these are variables as height increases. But this pressure acting on it, on this surface, you can calculate is about 800 to 1000 tons of weight. That much weight is there. I can't lift it because this is on the glass plate. You can imagine an atmospheric column. Column like that, which is equal to 76 centimeter of mercury. So you can take 76 centimeter H, density of mercury 13.6 into G 981. That also you can calculate. Okay, now I have to pull it up. Can you come and slowly try to pull this up, vertically up. Slowly. She can't. You try. No tilting. See, when you tilt, good, she tried it cleverly. When you tilt, the opening comes there and air goes there. Then it will come out. So she is very sharp. So normally, if you try to pull it up, it is very difficult. Okay? Would a boy come here and try that? Yeah, please come. Anyone can come in because you can do that experiment. You must pull it up. Don't try to take it. You can always take it, no problem. But it is flat on this glass. The glass should be very clean. And this surface is perfectly smooth, super perfect. There should not be even a small speck of dust. And now I have to pull it vertically up. Come on. Oh, you could succeed. But you know what happened? When you were pulling, suddenly a hole comes here. And that hole creates the problem. So you should be very particular to pull it like this. And you are holding like this. That means an angular position always gives angular forces. And angular forces in physics are called torque. There is a word name called torque, angular. This is straight is force. This is becoming torque. So this torque is a very funny thing. Okay? And when you are walking through the streets, if you walk on a plantain fruit skin, you twist. A twist comes. And how do you fall? You go on rotating. You want to prevent the fall by rotating circular motion, creating an anti-torque and so on. If that succeeds, you will not fall. If that fails, you will fall down. So that is the idea of falling. Okay, balancing. But then pulling this is rather difficult. So you hold it like this and then pull straight away up. No, you don't put this hand. Yeah, see, he's taking the whole glass up. This is what I was expecting. If you do it correctly, this whole glass will come up. Try again. You are succeeding. Normally, yeah. This is what I expect. Okay, your name? Rudraksh. All Rudras are here. Thanks a lot. So we talk about gravitation, and more to know about gravitation. Which go? Yeah, you can. Anybody can do it, but this sheet is very important. You must purchase such a sheet. I was searching for such a sheet, and luckily last time when I came to Indore, I saw it in a shop. They had kept it in a packet and so on. So this is the right thing. My wife is reminding me of a funny experiment. This is a nice experiment. I will quickly go through because I would like to cover as much as possible. There are nice things to come. This is a disc with a narrow hole, very narrow hole. And the upper side, you have got a cap. That's all. So what I do is, I inflate the balloon. Then close it. Now the air comes through the very narrow hole and I am placing it over a glass sheet. Let us see what happens. Now it will float. It will easily float because air is coming through the disc bottom. So this fellow will easily travel. No, this is all right. See, no friction. This is something like no friction. See? Free motion. This is called free motion. it won't work here because of the friction. Yeah? What do you want? Okay. Free motion. You are seeing first time free motion in the world. There is no free motion possible, always there is friction and gravitation. This is free motion. Air is coming out of the bottom and is floating on the glass. If you have got 2 or 3 of them, you can play basketball. Okay, fine. Thank you very much. So you have seen free motion. Now I will tell you something about gravitation. More about gravitation. I have got a simple pendulum. This is actually, it is called simple pendulum, but it is very complicated thing. All the physics studied, I feel even now, this is a very, very interesting as well as complicated thing. So I am going to oscillate the simple pendulum. You know, simple pendulum, candelabrum was hanging in the church. Galileo watched it. He saw it was moving like this in the wind, candle supporting thing. He counted with the pulse. He found out the time is always a constant. That is historical. But now we do that, simple pendulum. The time, this is called length. This is a bob. Known things to you. But I am going to count it. This is 0, 1, 2. Oh no! This is the problem with the students in many +1 class. Your counting is wrong. I will tell you. Even when I went as examiner, I told the student, come on, you count. So he started counting wrongly like this. You see? 1, 2, 3, 4, 5. This is wrong. One oscillation is this. This is one oscillation. So you have to count not 1. 0, 1, 2, 3. Okay, fine. You have learned how to count the period. This simple pendulum, if I repeat it any number of times, the time will be the same. Okay? So now, this pendulum, I will say, is not oscillating, it is dancing in Earth's gravitational field. Let us enjoy the motion of the simple pendulum in Earth's gravitational field. I am going to make you hear the music of a simple pendulum as it dances. What you should do is, when you say 1, 2, 3, you must clap your hand. Clap, goes back, clap, second clap, third clap. So you are synchronizing time with the oscillation of simple pendulum, which is synchronizing its oscillation with gravitational field. Great thing. So we are going to do that experiment. Let us see what happens. Now I will tell you when to start clapping, okay? Don't do that now. Clap! I am getting few sounds of the beats. I want only one beat, simultaneous. In physics, this word simultaneous has got, instantaneous has got great significance. You are going to learn some physics from this. Okay, fine. So now we will start. I should get only one clap the moment it touches the extreme point. Not now, next one onwards. Yes. See how periodic, repetitive, same period. Even when the amplitude dies down. Come on! In Indore only I am getting this new problem. Only clap for a simple pendulum. Now you have seen the beat frequency, right? Tack, tack, tack. Did you get a frequency? That sound? Now without a simple pendulum, can you do it? I am going to try again, okay? But you should continue when I stop the pendulum, okay? Not now, next one onwards. Simple pendulum will come and beat you. This is called synchrony with nature. Okay? So how was it beating? Can you take it from memory? Let me see. What you have heard is a periodic motion. You beat with me. You are going off the beat. Anyway, simple pendulum will also do the same drama. If I want a simple pendulum to follow this path in the music, I will make it do that. Okay, I will make this do that. Clap a little bit sign conscious. Okay, so now, come on. So Galileo noted two things. Time from one end to another end is always a constant. As the length decreases, frequency increases. These two are related to gravitation. So this pendulum is actually dancing in Earth's field and telling you something interesting about gravitation. So now I will tell you that this periodic oscillation of a simple pendulum has much more to do with the universe. I have got another bob. Here I have placed it. I have this simple pendulum. So two masses are coming close, 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 close. Let us see what happens. This simple pendulum is in gravitational field, something which you have never expected. And this is the resting a mass. This is mass M1, mass M2. I am putting them close. Our physics says when two masses come close, there is a force. Talking about gravitation, right? Watch what is happening. Two masses. Say this is sun. This is earth. Come close. That's it. This is orbital motion due to some force. If you closely watch, you can see this is an elliptical path. Orbital motion. The earth goes on elliptical path around the sun. I am not doing any jugglery. Because there is an attractive force. You have learned when two things attract, the motion is conic section, elliptical, circular, parabolic. So they must be attracting each other. You may be wondering, how dare this professor show this? Because there is a force between them, very simple. How come this force came? Can one of you come here to see the secret? So this is a force, actually it is true, but this force was not gravitational force. So let us try to see what is inside this pendulum. So I am trying to open it. You can purchase gems for 30 rupees or so. You can make a nice simple pendulum. Eat a chocolate also. I am opening it. What do you see? Magnet. There's a magnet there. Okay? So there is a small circular magnet I have placed inside the bob. So it is magnet to magnet interaction, which is a replica of solar motion. Okay? Will that move?
If we do without magnet, will it do the same?
No. That's what I have been telling. Good. You are in the plus one.
11.
11. That is called, we call it plus one, plus two in Kerala. Very good. Good question. So students are asking questions now. The tendency to ask question is very, very important. Now, we will have a demonstration. I have told you about various kinds of motion at a basketball. About conservation laws in physics. So this was about gravitational force and also how force between two particles with inverse square law can represent conic sections of motion. Oh yeah, yeah. Now I am going to talk something about collisions in physics. I want two students to come who have not come here. Please come. Fine. Two students. Okay. Come on, come on. Okay, you come on. I will give you some job, don't worry. This is a basketball I have given you. And, okay. This is a tennis ball I have given you. You will also be participating. You are holding a basketball which is big. When I say 1, 2, 3, you have to leave the ball. It should be instantaneous, as I told you. You have come here earlier?
No, sir.
Okay, fine. And hold it like this. When I say 3, instantaneous, you must release it. Not 1 second earlier, not 1 second later. In physics, instantaneous has got a lot of ideas. So basketball, heavy. It rebounds. Why it rebounds? Elasticity. And why did you hear a sound? It lost energy. I dropped it from here. The height goes on decreasing because every time, are you a good basketball player?
Yeah, I have been a roll ball player.
Roll ball.
Yes, sir.
So you don't roll it, hold it. The same thing you have to do it. You hold it this way. And then when I say 1, 2, 3, you have to release. The moment I say 3. 1, 2, 3. I didn't ask you to put it. Repeat it. You don't do it. 1, 2, 3. It should be instantaneous. If it is a little delay, there will be a problem. Now these two gentlemen will, okay, come here. Oh, good advice. She says you get down. Okay. No, it's okay. Hold my hand. I will not fall down, don't worry. You don't fall down. Come on, both of you. Okay, nice. Now, you come this side. This is basketball, which is heavier. And it travels with a velocity. Mass into velocity is known as momentum. Mass into velocity is known as momentum. So this has got a momentum. This guy has got a motorbike. He is traveling with great momentum. That is it. Because this is very heavy, mass into velocity. And hold it like what I said. When I said 1, 2, 3, you have to drop it. 1, 2, 3. Hey Baba, I will call those girls. 1, 2, 3. You are always delaying a little bit. What about you? 1, 2, 3. You will all be bad players, cricket players. Because somebody is standing in the slip, the moment the batsman hits it, immediately you must fly and catch. When by the time you fly and catch, the ball will be in the boundary. Okay? So let us see whether it works. You got the idea. You have to try the same if they fail. Okay? You are in the waiting list. So now, hold it horizontally. Now come on. Hold it horizontally above it. You are also running a motorbike. This fellow is, you are the motorbike person. Okay? This is motorbike. And this is a truck. A truck and motorbike are going to collide. Okay, a truck and a motorbike both are falling down at the same velocity because it is gravitational pull and all that. And then touch it here, put it touching here. No, you can touch the ball. Okay. And then this ball should be perfectly normal. No, don't put it obliquely, because otherwise you will have an oblique impact. We want a direct impact. So you hold it like this. It should be vertical. And when I say 1, 2, 3, both of you leave it like that. And then this basketball will travel first, hit the ground, return, and when he returns, tennis ball will come and hit on it. Thanks to Saraf G, because he was talking on nuclear collisions. Here it is basketball, tennis ball collision. But still both are the same. So when they collide, a law, basic law in nature is obeyed, that is called law of conservation of momentum. Which means heavier ball will lose, another ball will gain, somebody is going to hand over. Come on, you take a little momentum from me. So when a motorbike and a truck collides, who gets momentum? Motorbike gets momentum. This fellow will be thrown away. Are you afraid? Nothing. We are only talking here. So let us see how the collision happens. I wish it is a straight collision, and I wish your bulbs are not distributed, damaged. With both hands, it's parallel. When I say 1, 2, 3, you have to drop. 2 obedient students are not a welcome change. Go down. You will have to come. Huh? Come on, hold it like that. Now the game starts. Only when I say 3, you drop it, don't drop it otherwise. And you should immediately drop it. Okay? 1, 2, 3. What happened? The motorbike dived. It is a direct collision. What is your name? Huh? And your name? Oh, don't drive motorbike. Go. Come on. So this is the collision experiment. So you are the tennis motorbike lady. You are the basketball lady. Practice now. Wait. You also hold it like this. When I say 3 simultaneous, it should be simultaneous. If it is simultaneous, the audience will say yes, or they say no. Okay? Come on. 1, 2, 3. No, this was late. Repeat. 1, 2, 3. Oh. Now let us see. If you drive motorbike like this, what will happen? Come on. Come on, Piyush. Hold the ball on it. Place the ball on it. Vertically up. No, if there is a slanting, you will have oblique collision. That is the only problem. Okay? Are you ready?
Yes, sir.
Yes, sir. Smart. Are you ready? 1, 2, 3. Not bad. Very good. It was good. Female motorbikes get less hurt. Okay. So this is a famous law of conservation of momentum. It is a universal law. Okay. Momentum before impact is equal to momentum after impact. Total momentum will not change. This is the idea. If you had watched this basketball, you would have seen it comes to lesser height. Nobody watched it because it lost some momentum. So whenever 2 bodies collide, total momentum before impact equals total momentum. Why nothing is coming? Total momentum before impact is equal to total momentum. Total momentum before impact is total momentum. This side is responding, that side is silent. Okay, fine. So this is about linear momentum. I am now going to talk to you about angular momentum. I want 2 people to come on the stage. Wheel. Angular momentum. 2 people come. Come on. Oh, very good. I wanted. You have not come earlier, I hope. Any person who has come once, please don't repeat. You came for balloon. You also came for balloon? Blowing balloon. You also came for balloon? So you can go back and 2 more new people. They have already come and participated, that's why. Okay. You were helping her wife only. Okay, this is a wheel. Yeah, come on. You felt like coming. Oh, so many people. Okay. Now, this is a wheel. I am going a little faster now to accommodate for time because it is 12:37. If I go normally like this, I will be finishing at 4 o'clock. So, somebody can give me a caution, sir, another 5 minutes we will stop. Okay? Because before you end the program, I want to give a video also, nice video. So, 15 minutes. Thank you. Okay. A wheel is this. If I leave the wheel, it falls down. Why? Gravity pulls it, whatever it is. But when we go cycling, it doesn't fall down. How does it happen? So, you come down, stay there, niche ho. Okay. Now what you have to do is, you have to rotate it, catching anywhere. Okay, wait. Rotate. Rotate fast. No, not like that. With both hands. Go on rotating. Fast. Okay. 15 minutes is creating problem. Dubeji, please come. Thank you. I will ask Professor to help me because I would have shown more drama. No, I will hold it, sir. Oh, you want it like that? Okay, he wants this way. Good, leave it. Leave it. It is not falling. This is due to conservation of momentum. But angular momentum, this is called angular momentum. Now the momentum vector is on this direction. Students can ask me why this is spinning. All those are big physics to go up to 4 o'clock. So we will stop it here. Why cycles do not fall down? Because go on pedaling. That is the message now you get. Conservation of angular momentum. Now there is only 15 minutes left behind. So thank you very much. I am skipping fast with the last show. Vechiko. You know, what do you? Two or three students come. Two or three students, please come, hurry up, because we have to go fast. Yeah, I am talking about what is called center of mass. Hold this one by one. One to you. You can hold it. Now, center of mass is a place where the mass is located. I can find out the center of mass like this. Well, this is where I am holding it. Okay? Now, you place your scale across on the scale, on it you place, and it should not fall down. You try to find out the center of mass. Very good. Now, one of you come here, one of you go there. One of you come here, both of you place at this center of mass point, this center of mass point, so that this doesn't fall down. If it falls down, I will not repeat it. You have to find out exact point where you have to hold it so that this doesn't fall. Very good. Next team. And one more team fellow, this side. You have to place on the end of those so that doesn't fall. Not this one, these two. So there, another person, no scale. There is only one scale. So let it fall down. Don't worry, it's all right. Put on that video. Now you enjoy a video on center of mass, because all that I have got is 15 minutes. Oh, give him. I wanted to see his show, but because of time factor only, please come. You are such a great man. You can go. You will see a video after this. I will put a video on center of mass as a concluding part of the program. Please come to the stage. Give a good clap to Professor Dubey. He has started, inspired by people like us, stage shows. He has also started doing stage shows at this young age. And so he told me, I have got a great idea, I will present it. I said, definitely I will fit in you also in my show. So it's my pleasure to have Professor Dubey along with me. And he will just, you wanted this thing, sir? Mike?
I forgot to put this button.
Is it a slogan against me? Professor Dubey is a very active member of IAPT, and Indore IAPT, Madhya Pradesh, RC is a president, and so if he is very active, and we have done some stage shows together.
I will take few seconds. This is some acrylic bar and highly polished, finished piece. So if I will throw light inside it, you will see the total internal reflection phenomenon. This is visible?
Can you see the light total internal reflection? If you see, you give a clap. Next one also.
Next one.
Next one.
See, there is one.
You have it with you?
Huh?
You have brought it?
Yeah.
That's it.
Demonstration related with Lorentz force. Means Lorentz force, we must have magnetic field. I think my voice is there. आ रही है? हाँ. So if you want to demonstrate Lorentz force, then magnetic field must be there. One charge particle. So we will take electron. Right? So current flowing through a copper wire, we will get electron. So we will try that. If electron enters in a magnetic field, it will experience some force. So if electron will experience some force, then that wire in which electron is flowing will feel some force. So it should disturb, it should move, it should change its position. So let us try it. So you can do this setup with simple Duracell. The movement will be slow. And I am here using some lithium ion battery cell. It is some 3.7 volt. So what I am doing, these are stacks of magnets. So many magnets are, I kept it here. And this is cell, right? Magnet and cell. And I want to put this wire frame. This current should flow through this wire. So this upper tip, I will put it here. Lower tip will touch in this area. So current will flow, right? Okay. Right, I will put it. So if current will flow, what I am doing? I am connecting the upper tip of the cell and lower portion. So what I am doing? What I am doing? I am doing short circuiting, right? Means I am connecting this, I am putting this here, like this. Okay? So this cell will be short circuited. High current will flow through this copper wire. Okay? So this everything will be damaged. I am seeing this is getting hot, right? So we will see, it's a very crude demonstration, right? We don't know whether electron and magnetic field, they are perpendicular or not. But we are trying at random. I am putting this washer so that this tip will constrain to move inside this. Otherwise this loop will move away from the system. Yeah, wonderful. Nice demonstration of Lorentz force. See, this system is not getting damaged. It is moving with high angular velocity, right? If the lower portion, see carefully, can anybody wants to come here? Aajao. Someone from the last bench, last seat, that girl, come here. हाँ आप जो सिर घुमा रही हैं, हाँ यस आप ही आ जाए, हाँ यस यस आ जाओ. Now because see, when this coil will move, right, its lower contact will get break. If it is in constant touch, high current will flow through the copper wire. So when it get in touch with the lower this magnet, current will flow and it will rotate. So this lower end is not in direct continuous contact with the magnet. If it is in constant continuous, high current will flow and it will damage this cell. I think this 30% efficiency of the cell is out. So you students try to learn what is Lorentz equation, okay? Because you are not studying +1, +2 and degree. Okay. We are just about to see a film show and end the program because they want to finish it within 15 minutes. Already we have lost another 10 minutes. One more point, if you want, you will do at your home, you will find that it will not rotate. Call. When the current will flow at the contact point, carbon will be deposited. So you must have one sandpaper. and you have to remove this carbon at the contact point.
Okay.
Thank you, sir.
Oh, no mention. It's a pleasure to watch you. Now, this is a show on center of mass. This is the last program.
for Vinaya.
Hello, hello, hello. Thank you, Anant Krishnan, sir, for your mesmerizing show. It was really fantastic. In so simple way, you explained the basic concepts of pressure, Bernoulli's principle, torque, and free motion, about the periodic oscillations and magnet-magnet interaction, and the law of conservation of momentum, both linear and angular momentum. It was really fantastic. And then P.K. Dubey sir also explained the concept of Lorentz force. So I hope the students would have enjoyed a lot. And one faculty told me now only that I can watch this show till evening. So it's a big round of applause for sir. Even I can watch, sir, for a whole day. It was really very nice. So I would like to inform you, due to some unavoidable reasons, our VC, Honorable VC, is little bit late. We are waiting for her, but still, since we are getting late for our next program, so I'm commencing our program further. I'm delighted to stand before you today to share the excitements and wonders of the scientific world as students from different parts of the country will showcase their innovations in this science exhibition. This event is not just an opportunity to display their projects, but it is a celebration of curiosity, innovation, and the relentless pursuit of knowledge. They are the nexus of knowledge and imagination where theoretical concepts are transferred into practical models. They aim to enhance people's understanding of the world and the scientific method while sparking curiosity and promoting science literacy. It also fosters teamwork and communication skills. It is the mark of undying tradition to invoke the Almighty at the beginning of the event. In our case, it is mid of the event actually. So let's begin this pleasant afternoon with a traditional light lamping ceremony as a tribute to Ma Saraswati, the goddess of knowledge. So I now call upon our honorable guest of honor, Dr. Piyush Saxena, sir, Head Project Coordination Cell and Laser Electronic Division, Raja Ramanna, Center for Advanced Technology, Indore. Our judges, Dr. Anant Krishnan and Dr. S.K. Joshi. Our EC member of IAPT, Dr. P.K. Dubey, Dr. B.D. Srivastava, President of IAPT, and convener of this program, Dr. Jiten Tripathi, HODs, Naveen Joshi sir, Pradeep Joshi sir, and Ruchi madam for the lamp lighting ceremony. Now it's time to welcome our guest. In this series, I would like Dr. Jiten Tripathi sir to give a sampling as a token of appreciation to our honored guest, Dr. Piyush Saxena. I invite Dr. Pradeep Joshi ji to greet our judge and expert of science show, Dr. Anant Krishnan ji, by gifting a sapling. नीचे का Thank you, sir. I call upon Dr. Ruchi Srivastava to welcome our other judge, Dr. S.K. Joshi, by presenting a sapling. Thanks, ma'am. Now I request Dr. Pradeep Joshi, sir, HOD Mathematics, to say a few words about the institutional and motivational words to participants.
Good afternoon. Namaskar. On the behalf of Institute of Science and Research, IPS Academy, welcome to you. Celebrating the National IPSA Science Exhibition and Science Show, it is our great pleasure to honor to welcome our resource persons, Chief Guest, Honorable VC Madam, Dr. Renu Jain, Guest of Honor, Dr. Piyush Saxena, sir, Head Laser Department, CAT, Indore, our science show expert, Dr. Anant Krishnan, and one of the judge from Bengaluru, Dr. B.D. Srivastava, Chairman, President, IAPT, Dr. Pradeep Dubey, sir, EC member, and Judge, Dr. S.K. Joshi, sir, and all the participants from various parts of the country. I congratulate to all participants for participating in this event. Indore Professional Science Academy IPSA is one of the Central India's largest educational hub premiers, playing a major role to develop Indore as a Central India's most preferable education center. It is spread in area of 60 acres, 3 campuses, and we house the most profitable, intellectual, honing and experienced educational assembly. IPSA is a successor to Indore Public School, which is vision realized by architect Achal Chaudhary sir from IIT Kharagpur, a renowned architect. Institute of Science and Research, ISR IPS Academy, is one of the premier educational institute in Central India's imparting education in the field of basic sciences. Today, the institute offers courses as both undergraduate and postgraduate levels in biotechnology, chemistry, computer science, electronics, mathematics, physics, and library science. ISR offers 7 undergraduate courses and 6 postgraduate courses. Since its commencement, the department has endeavors to set standard as per excellence by providing quality education in various branches of science with the assistance of well-qualified and experienced faculty members. I congratulate to all participants who is participating in this exhibition, and thank you so much.
Thank you, Joshi sir. Now I invite Dr. Jiten Tripathi sir to say a few words about this science exhibition and kindly declare the result of essay competition also. Please, sir.
Good afternoon, Saxena sir, all the HODs, B.D. Srivastava sir, Pradeep Dubey sir, S.K. Joshi sir, Limye sir, all the participants and students. एक्चुअली में हम जो यहाँ पर इकट्ठे हुए हैं, ये हमारे जो प्रणेता, हम सब ISR के ISR से रिलेटेड हैं, तो जो बाबूलाल सराफ सर थे, इन्होंने ही ISR इंस्टीट्यूट को बनाया था. तो हमारे जो पहले फाउंडर डायरेक्टर थे वो बाबूलाल सराफ सर थे, उनका 100वां बर्थ ईयर है ये. तो इसको मनाने के लिए एक्चुअली में 2023 2 दिसंबर को हुआ था सर का बर्थ, तो उसको मनाने के लिए हम सब यहाँ इकट्ठे हुए हैं। तो उसके लिए हमने 4 अलग अलग इवेंट नेशनल लेवल के प्लान किए थे। ये आज जो हो रहा है ये हमारा 3rd नंबर का इवेंट है, जिसमें पहला इवेंट हमने किया था कि स्कूल टीचर्स के लिए हमने एक वर्कशॉप की थी, उसमें तकरीबन 30 पार्टिसिपेंट्स हमने लिए थे और ऑल ओवर इंडिया से हमको पार्टिसिपेंट्स मिले थे। सेकेंड इवेंट जो जैसा मैडम ने बताया कि अभी मुझे उसका रिजल्ट भी डिक्लेयर करना है, ऐसे कॉम्पिटिशन था, नेशनल लेवल ऐसे कॉम्पिटिशन था। तीसरा इवेंट जो हमारा है ये साइंस एग्जीबिशन, नेशनल साइंस IPSA साइंस एग्जीबिशन, और साथ में साइंस शो, ये हमारा आज का 3rd इवेंट था। और इसकी सीरीज में जो लास्ट इवेंट है हमारा दैट इज ऑन 11 to 16 मार्च 2024, दैट इज फॉर कॉलेज टीचर्स एंड PG स्टूडेंट्स। वो भी एक एक्सपेरिमेंटल वर्कशॉप है, वो हमारा लास्ट इवेंट होगा और वो 11 मार्च से हमारे स्टार्ट होगा जो इवेंट रहेगा। तो इस तरीके से हमने 4 नेशनल लेवल इवेंट प्लान किए थे सराफ सर को याद करने के लिए और हमारी तरफ से उनको ट्रिब्यूट देने के लिए। इसमें हम बहुत आभारी हैं IAPT के, RC9 के, उन्होंने हमारा हरदम साथ दिया और साथ देने के साथ साथ बहुत सारा फाइनेंशियल सपोर्ट भी उन्होंने हमको दिया। तो आई एम थैंकफुल टू IAPT एंड RC9 ऑल्सो। Now I'll declare the result of national essay competition. So, in memory of late Babulal Saraf, we organized essay competition for school and college students. In total, we have got more than 100 entries, and after the scrutiny, we have selected 30 essays. Out of 30, 20 were of the college student and 10 from the school students. Date of submission was 31st October 2023. जजेस ऑफ द ऐसे कंप्लीशन हुआ डॉक्टर SK जोशी सर, अभी भी हमारे साथ हैं यहाँ पर, रिटायर्ड प्रिंसिपल गवर्नमेंट PG कॉलेज PG आर्ट्स एंड साइंस कॉलेज रतलाम, एंड मिस इंदु कुमारी PG टीचर ऑफ फिजिक्स इन स्कूल ऑफ पुणे। एंड द विनर्स आर इन कॉलेज कैटेगरी, द फर्स्ट प्राइज गोज टू भाग्यश्री परिमिता, क्लास BSc फर्स्ट ईयर फ्रॉम भुवनेश्वर ओडिशा, first prize, and the second one is Saurav Datta, BSc Physics Honor 5th semester, Asutosh College, Kolkata, West Bengal। ये हमारे इस कॉलेज कैटेगरी के विनर हैं, एंड स्कूल कैटेगरी के विनर्स हैं। फर्स्ट प्राइज गोज टू प्रीति गुप्ता, क्लास 11th, स्कूल नेम DDB DAV, सेंटेनरी पब्लिक स्कूल, फिरोजपुर कैंट। And the second prize is for Tejal Jagdish Chinchole, 11th, RSCV and Arts and Junior College, मेहरगांव धुले। ये सेकंड प्राइज है। इनको ये जो भी विनर हैं, जब हमारा 11 से 16 का प्रोग्राम होगा मार्च में, we will invite them और हम वहां पर इनको कैश प्राइज हैंड ओवर करेंगे on 11th of March। Okay, thank you very much।
Thank you, sir, for your valuable information. The first prize for essay is 5,100 rupees, and the second prize for essay competition is 3,100 rupees, separately for school and college students. With great pleasure, now I would like to invite our one of the judges, Dr. SK Joshi, sir, to say a few words about late Professor Babulal Saraf. Before I invite him, I would like to give his brief introduction. He pursued his PhD from Vikram University, Ujjain. He was principal in Government Postgraduate Arts and Science College, Ratlam. His research areas of interest are X-ray spectroscopy and condensed matter physics. He has 77 published research papers in national and international journals and has guided 7 students for PhD. To present research papers at various international conferences, he visited USA, UK, Japan, Germany, France, Sweden, Australia, Italy, China, and Poland. As a short visitorship, he worked in the Dewsbury Laboratory of England in 1994 and in Hirosaki University, North Japan in the year 2000. He has published a book on X-ray spectroscopy and allied areas. He was an executive council member of IAPT from 2000 to 2002 and from 2007 to 2009, and also vice president of IAPT Central Zone from 2013 to 15 and from 2016 to 18. At present, he is the national coordinator of essay competition NCEWP since 2019. Dr. S.K. Joshi, sir, please to come. Please, sir.
इस सभागृह में उपस्थित सभी वरिष्ठ वैज्ञानिक, मेरे प्रोफेसर साथी, IPS एकेडमी का स्टाफ और यहाँ हॉल में बैठे हुए सभी छात्र छात्राएं, मुझे कहा गया है कि मैं प्रोफेसर सराफ के बारे में 5 मिनट का समय कुछ कहूँ। देखिए, सबसे पहले तो मैं उनको नमन करता हूँ, क्योंकि पहली विज़िट मेरी जो हुई प्रोफेसर सराफ के साथ इंटरेक्शन जो हुआ वो 1978 में हुआ, 1978। एट दैट टाइम आई वॉज ए यंग लेक्चरर इन SN कॉलेज खंडवा, और हम लोगों का 10 छात्रों का MSc का एक ग्रुप था जो एजुकेशनल टूर के लिए निकला था, और हम सबसे पहले जयपुर ही पहुँचे। उस समय सराफ साहब वहाँ CDP, सेंटर फॉर डेवलपमेंट ऑफ फिज़िक्स एजुकेशन, इसको ऑर्गेनाइज़ किया था उन्होंने, और बहुत अच्छा उसको रखा था वहाँ जयपुर में। हम लोगों ने उसको देखा, तभी मुझे लगा कि ये फ़िज़िक्स के इतने अच्छे एक्सपेरिमेंट्स इन्होंने डेवलप किए हैं यूनिवर्सिटी ऑफ राजस्थान में। वो यूनिवर्सिटी लीडरशिप प्रोजेक्ट भी था। जैसा कि उनको मैंने बताया कि सर मैं भी मध्य प्रदेश से हूँ और आप रहने वाले बदनावर के हैं, तो मैं बहुत ज़्यादा दूर नहीं, अभी खंडवा में पोस्टेड हूँ। तो बोले अच्छा आप कैसे आए, हमारे बारे में आपको कैसे मालूम पड़ा, सारी चीज़ें उन्होंने एक पर्सनल वे में डिस्कस की। आज मेरे पास वो सर्टिफिकेट भी है उनका। उन्होंने कहा एक अटेंडेंस का सर्टिफिकेट मैं आपको देता हूँ, क्योंकि आप गवर्नमेंट कॉलेज से हैं, हो सकता है आपके प्रिंसिपल पूछें कि आप गए भी थे कि नहीं, कि घूम फिर के आ गए, चित्तौड़गढ़ का किला देख के वापस तो नहीं आ गए। तो वो मैंने सर्टिफिकेट संभाल के उनके साइन का ऑन द लेटर हेड ऑफ यूनिवर्सिटी ऑफ राजस्थान रखा हुआ है। दूसरा फिर क्या हुआ कि उसके बाद हम लोग नौकरी में थे, फिर सराफ साहब से संपर्क आया हमारा 1994 में, जब मैं रतलाम कॉलेज में प्रोफेसर था फिजिक्स का। हमारे डिपार्टमेंट में सर आए और 3 साल तक उनका जो प्रोजेक्ट था जो उन्होंने चलाया, मेरे उनसे यद्यपि मैं प्रोजेक्ट में डायरेक्ट जुड़ा हुआ नहीं था, और लोग थे हमारे कुछ कलीग्स थे, पर कई बार उनसे कई भौतिकी के उन बारीक चीज़ों पे चर्चा होती थी, तो उससे ये लगता था कि हमें हर पल कोई नया ज्ञान प्राप्त हो रहा है। मैं ये कहूँगा सबसे पहली बात तो ये थी कि वहाँ कोई ऐसा इंफ्रास्ट्रक्चर नहीं था, लेकिन सर ने उस प्रोजेक्ट के लिए 6 कॉलेजों को उसमें चुना था, जिसमें होलकर साइंस कॉलेज, धार कॉलेज, उसके बाद में हमारा खुद का कॉलेज तो सब सेंटर था, रतलाम आर्ट्स एंड साइंस कॉलेज, फिर नीमच का कॉलेज, मंदसौर, और एक अंडर ग्रेजुएट कॉलेज उनका लिया था बड़नगर का। इन सब में जो है न्यूक्लियर फिजिक्स के जो एक्सपेरिमेंट्स हैं उन्होंने वहाँ सब सेंटर पे डिज़ाइन किए। मेरे सामने सक्सेना साहब बैठे हैं, मैं ये बताना चाहूँगा कि बहुत सारे एक्सपेरिमेंट जो हमारे इन MP कॉलेजेस में, या इवन मैं तो कहूँगा कुछ यूनिवर्सिटीज़ में भी नहीं होंगे, वो वहाँ डेवलप किए गए। वो बहुत बड़ी चीज़ थी। उनको करीब से हमने देखा कि किस तरह से उन्होंने सिंटिलेशन स्पेक्ट्रोमीटर के प्रयोग हैं, फिर उसके बाद में बीटा रे वाला प्रयोग है, एयर ट्रैक का एक्सपेरिमेंट है, जो कुछ क्वांटम इलेक्ट्रोडायनामिक्स की बात की जाए, ऐसे सारे एक्सपेरिमेंट्स उन्होंने डेवलप किए और इन कॉलेजेस को दिए हैं। उस समय रिसोर्स प्राप्त करना या सोर्स जैसे सीजियम है या कोई भी मंगवाते थे तो अवेलेबल थे। अब यह है कि उसके आज इतने सालों बाद मुझे अभी बताया गया कि शायद सोर्सेस की प्रॉब्लम है और इसलिए कुछ जगह वो एक्सपेरिमेंट्स बंद हो गए हैं। सराफ साहब से बहुत कुछ सीखने को मिला। जब भी उनसे कोई बात होती थी फिजिक्स की एक अंदरूनी बात, या जिसको कहना चाहिए कंसेप्ट, हम जो पढ़ते थे वो बहुत और क्लियर होता था कि नहीं सर ने आज हमको ये बताया है। और सबसे बड़ी बात ये थी कि उन्होंने एक दिन मेरे को कहा कि सब एक्सपेरिमेंट तो दे दिए कॉलेजों में, अब दिक्कत ये कि बोले आप लोग जो पढ़ाते हो न्यूक्लियर फिजिक्स, वो या तो BN श्रीवास्तव की किताब से पढ़ाते होंगे, या आप बोले मैंने सुना प्रगति प्रकाशन की कोई किताबें आ गई हैं। तो बोले मुझे लगता है कि टीचर्स को किसी अच्छे प्रोफेसर को बुला के न्यूक्लियर फिजिक्स भी बताई जाए। प्रोफेसर BK शर्मा को उन्होंने यूनिवर्सिटी ऑफ राजस्थान से बुलवाया, और मैं कहता हूँ यहाँ शायद सभागृह में कुछ लोग होंगे फिजिक्स के जो उन्होंने BK शर्मा साहब के लेक्चर अटेंड किए होंगे। मैं तो ये कह सकता हूँ कि उस तरह की जो न्यूक्लियर फिजिक्स पढ़ाई गई, बहुत सीनियर प्रोफेसर्स भी इंदौर से भी थे मेरे साथ में, मैं कुछ लोगों के नाम ले सकता हूँ। प्रोफेसर घारपुरे थे, प्रोफेसर वेलनकर थे। उन लोगों ने एक्सेप्ट किया कि जो न्यूक्लियर फिजिक्स हम लोगों को अभी तक कहीं डाउट था, वो इन कोर्सेज से जो है बिकॉज ऑफ प्रोफेसर सराफ आज हमको ये ज्ञान प्राप्त हो रहा है, नहीं तो कौन आके बताएगा। तो ऐसी कई चीज़ें थी जो सर के उसमें हमने सीखी है वहाँ। मैं बहुत विनम्र मतलब उनको उससे याद करता हूँ, मेरी बहुत रिस्पेक्ट है उनके प्रति। फिर तीसरी चीज़ें हुई कि मैं खुद प्रिंसिपल बना और पहला पोस्टिंग ही बदनावर हुआ। जैसे ही सर यहाँ IPS एकेडमी में थे, उनको खबर हुई कि सर जो हैं बदनावर आ गए। तो एक बार क्या हुआ, बदनावर आए, उनके भतीजे क्या रुके, दिस इज़ पर्सनल डायलॉग। मुझे फ़ोन किया भतीजे ने कि सर यहाँ आए हुए हैं और आपको याद कर रहे हैं, हमारा मेडिकल स्टोर है उसके पीछे ही मकान है, तो आप आ जाइए। मैं वहाँ गया, बोले भाई देखो एक बात है, आपसे मेरे को कोई स्पष्ट कहने में वो नहीं है। बोले आप यहाँ प्रिंसिपल बने हो, बदनावर में केवल आर्ट्स और कॉमर्स है, आप प्रयास करिए कम से कम साइंस तो खुलवाइए। मेरी जगह है, बोले मेरा जन्म स्थान है बदनावर का हूँ, तो ये तो लगे कि यहाँ साइंस खुली। मैंने कहा सर मैं पत्र व्यवहार करता हूँ, पत्र व्यवहार भी किया, कमरों की स्वीकृति लाए। उस समय अर्चना चिटनीस जो है एजुकेशन मिनिस्टर थी, हम लोग गए, सराफ साहब का भी नाम लिया। हमने कहा सब देखिए इतने बड़े प्रोफेसर हैं और ये इतनी छोटी चीज़ है आपके लिए, आप डिक्लेयर करिए कि साइंस खुल रही है अगले सत्र से। बोले साइंस तो हम खोल देंगे, फिर कमरे कहाँ हैं आपके पास। जन भागीदारी अध्यक्ष को भी ले गए तत्कालीन जो थे। 6 कमरों की स्वीकृति और 50 लाख रुपए हमें उस समय मिला, कॉलेज में साइंस शुरू हुई। उसके बाद में फिर वापस सर का आना हुआ। फिर बोले एक समस्या और आ गई है, पर्सनल बात बताते थे। बोले मेरे यहाँ चलो घर पे गए, उनके जहाँ रेसिडेंस था, मैडम सराफ भी थी। बोले देखो ये सब हमारा घर कैसा है, सर ने इसी को एग्जीबिशन बना दिया है। स्कूल लेवल के जितने एक्सपेरिमेंट्स थे, ही वॉज मेंटेनिंग दोज एक्सपेरिमेंट्स इन हिज हाउस। फिर बोले कि इसको कैसे करें, तो वहाँ एक नंदराम चोपड़ा स्कूल है, वहाँ के प्रिंसिपल से बात हुई कि भाई आप ले सकते हो क्या, सब दे देते हैं आपको। वो बोले सर हम कहाँ रखेंगे, बिल्डिंग में जगह नहीं, कोई देखने वाला नहीं। सराफ साहब बोले कि मैं जाके वहाँ डायरेक्टर स्कूल एजुकेशन से भी मिला, उनको ये कहा कि आप और कुछ मत करो, सारे एक्सपेरिमेंट्स में दे देता हूँ, एक आदमी को अपॉइंट कर दो जो इसका केयर टेकर हो कि कम से कम ये एक्सपेरिमेंट बताए जाएं, डिमॉन्स्ट्रेशन हो और वो चालू रहें। अनफॉर्चुनेटली गवर्नमेंट में कोई पोस्ट क्रिएट होती है, अभी सुबह ही डिस्कस हुआ, बहुत मुश्किल रहता है, फाइनेंस में जाती है वो पोस्ट क्रिएट होना बहुत मुश्किल है, और वो वैसी स्थिति रही। तो सराफ साहब को तो मैं पर्सनली मतलब मेरा इंटरेक्शन बहुत रहा है 78 से टिल हिज डेथ। जब उनकी डेथ हुई तब भी मैं पोस्टेड बदनावर में ही था, एंड वी हैड ए वेरी सैड न्यूज़ पूरे बदनावर के लिए भी और हमारे फिज़िक्स कम्युनिटी के लिए। मैं अपनी विनम्र श्रद्धांजलि भी देता हूँ उनको, और मैं IPS एकेडमी का इसलिए थैंकफुल हूँ कि कम से कम मेरे कुछ जो उनके साथ इंटरेक्शन है वो मैं आपके सामने रख सका। मैं ये कहूँगा कि प्रोफेसर सराफ ने एक बार बहुत ही इनफॉर्मल वे में हम लोग बैठे थे, रतलाम में चर्चा हो रही थी, तो मुझे आज भी उनके शब्द याद हैं। वो कहने लगे भाई देखो मैं यूनिवर्सिटी ऑफ राजस्थान में इतने साल से प्रोफेसर रहा, 1965 से लेके 85 तक प्रोफेसर एंड हेड भी रहा। मजाक हो रही थी मतलब चाय के समय, बोले बाकी मेरे को कभी वाइस चांसलर के लिए किसी ने कंसिडर नहीं किया। तो बोले जोशी जी आपका क्या कहना है। मैंने कहा सर देखिए कंट्री में 200 से ज़्यादा यूनिवर्सिटीज़ हैं, 200 से ज़्यादा यूनिवर्सिटीज़ हैं, वाइस चांसलर्स आते हैं 4 या 5 साल का कार्यकाल पूरा करके चले जाते हैं, एवरी 4 और 5 ईयर्स न्यू वाइस चांसलर कम्स। बाकी जब भी फिजिक्स एजुकेशन की चर्चा होगी देयर इज़ नो रिप्लेसमेंट ऑफ प्रोफेसर बाबूलाल सराफ। थैंक यू।
Thank you, Joshi sir, for sharing your views about Professor Babulal Saraf, your interaction and experience with him. And yes, it is true, we will never forget Dr. Babulal Saraf whenever we will talk about physics. And I would like to announce one more thing. very happy to announce that all the experiments designed by Professor Babulal Saraf are still working in our department, and our PG students keep on doing experiments on that. It's a privilege today that we have Dr. P.K. Dubey, Executive Member of IAPT, with us. I would like to give a brief introduction of Dr. P.K. Dubey, sir. He worked as a professor and head of the physics department at PMB Gujarati Science College, Indore. He pursued his BSc and MSc from Vikram University, Ujjain. He has done his PhD from RGPV Bhopal in accelerator physics. He has published 12 research papers in peer-reviewed journals. He has written 4 books on physics for PG students. Presently, he is an executive member of IAPT, president of the Central India region of Glass Blowing Society of India, and coordinator of the National Graduate Physics Examination. He has delivered more than 100 invited talks and physics stage shows in various institutes in India. He has teaching experience of 55 years. He is a recipient of Professor Babulal Saraf Memorial Award in 2023. Now I request Dr. P.K. Dubey, sir, to say a few words about the IAPT. Please, sir.
Respected Dr. Saxena ji, S.K. Joshi साहब, लम्हे साहब, श्रीवास्तव जी, हमारे आज के स्टेज शो के हीरो प्रोफेसर अनंत कृष्णन, मिसेज अनंत कृष्णन, बेंगलोर के गर्म माहौल से इंदौर के ठंडे माहौल में आके स्टेज शो देना, वो भी 80+ की एज में, वाकई में सोचने वाली बात है। एंड द मोस्ट इम्पॉर्टेंट थिंग कि आज के जो हीरो हैं, ये जो प्रिय विद्यार्थी बैठे हुए हैं, जो श्रोता हैं, ये हमारे लिए हीरो हैं। ये जो IAPT है, ये 1984 में इस्टेब्लिश हुआ। DP खंडेलवाल साहब ने इसे बनाया था, साथ में बाबूलाल सराफ और इन जैसे कई लोग थे। बाबूलाल सराफ साहब की जो एक विशेषता थी वो ये थी कि वो अच्छी भली नौकरी छोड़ छाड़ के, जिसमें उन्हें उनका जीवन बड़ा शांति से गुजरता था, छोड़ के वो जयपुर पहुंच गए। जयपुर पहुंच के उन्होंने उन प्रयोगों को बनाया जो कि भौतिकी को बच्चों के लिए आसान कर दे, जिसमें आप स्कूल के, कॉलेज के जो बच्चे हैं वो उनको आसानी से प्रयोग कर सकें, और अपना सारा जीवन वहाँ उन्होंने खपा दिया। तो IAPT जो है वो चूँकि IAPT से जुड़े हुए भी यही लोग हैं, खंडेलवाल साहब, नेक्स्ट इज बाबूलाल जी सराफ साहब, हंस साहब। तो अभी जो है हंस साहब और सराफ साहब का 100वां जन्म शताब्दी वर्ष मनाया गया। तो IAPT जो है बेसिकली बच्चों के और बच्चों को पढ़ाने वाले शिक्षकों के स्तर में, मतलब उनका शैक्षणिक कार्य भी अच्छे से हो, शिक्षकों में भी अभिरुचि जगाई जाए, इसके लिए हमेशा प्रयासरत रहता है। IAPT जो है बहुत तरह की एग्ज़ाम कंडक्ट करता है, जो विशेषकर स्कूल के बच्चों के लिए है। इसमें जो है नेशनल स्टैंडर्ड एग्जामिनेशन इन फिजिक्स, नेशनल स्टैंडर्ड एग्जामिनेशन इन केमिस्ट्री, नेशनल स्टैंडर्ड एग्जामिनेशन इन बायोलॉजी एंड नेशनल स्टैंडर्ड एग्जामिनेशन इन एस्ट्रोनॉमी। ये 10th 11th 12th के बच्चों के लिए होती है। उन्हें एक बार 200 रुपये की फ़ीस देना होती है, फिर उसके बाद वो 5-6 लेयर्स की डिफरेंट एग्ज़ाम्स को फेस करते हैं। उसके बाद उन्हें कोई पैसा नहीं देना होता है और वो नेशनल और इंटरनेशनल ओलंपियाड तक पहुंच जाते हैं। ओलंपियाड अगर बर्लिन में हो तो वहाँ के जाने का भी खर्चा उन्हें मिलेगा। ये जो जितने भी 5th लेयर तक पहुँचने में जहाँ भी उन्हें बुलाया जाएगा मिलेगा, उन्हें कोई पैसा नहीं देना पड़ता है। फिर एक जूनियर साइंस एग्ज़ाम भी होती है जो 8th, 9th, 10th के बच्चों के लिए होती है और ये सब होता है जुलाई में। तो आप लोग जो यहाँ बैठे हैं वो इसका ध्यान रखें कि आप अगली जुलाई में अपने टीचर से पूछें, हो सकता है आपके यहाँ सेंटर हो, अगर ना हो तो ये पूछें। ये जो इंटरनेशनल ओलंपियाड के लिए जो टीम बनती है ये रियल में भारत सरकार की ओर से प्रायोजित रहती है। HBCAC जो है, होमी भाभा सेंटर जो है फॉर स्कूल एजुकेशन, वो इसको प्रायोजित करता है। वैसे तो आपको ओलंपियाड के बहुत सारे लोग आ जाएंगे जो आपको ओलंपियाड में बिठाएंगे और सर्टिफिकेट भी देंगे, पर जो रियल ओलंपियाड है वो IAPT ऑर्गेनाइज करता है। IAPT के करीबन 10,000 के आसपास मेंबर्स हैं और इसका मुख्य उद्देश्य जो है वो ये है कि बच्चों को फिजिक्स फंडामेंटल्स इस तरीके से सिखाया जाए कि वो आने वाले समय में BSc में फिजिक्स ले। अभी जो NEP जो चल रहा है उसमें एक मेजर सब्जेक्ट होता है, जो आपने मेजर सब्जेक्ट लिया उसे में आपको MSc करने को मिलेगा अगर आप इंजीनियरिंग में नहीं गए। तो अगर आपने मेजर सब्जेक्ट फिजिक्स लिया तो आप MSc जो है वो फिजिक्स में कर पाएंगे। और चूँकि ये सराफ साहब को हमें याद करने का जो सबसे महत्वपूर्ण कारण ये है कि फिजिक्स से लोगों को डर लगता है बच्चों को, तो जितना आसान तरीके से उसे समझाया जाए, प्रयोग कराया जाए, उतना ही वो उसमें रुचि जागृत हो। और उसमें सराफ साहब ने अपना संपूर्ण जीवन जो है, एक महत्वपूर्ण बात है कि सराफ साहब मध्य प्रदेश के ही थे, बदनावर के थे। और इस सत्र में मुझे जो है प्रोफेसर बाबूलाल सराफ मेमोरियल अवार्ड जो है वो ये प्रयोगों को डेमोन्स्ट्रेशन करने के लिए ही दिया गया। तो मैं IAPT का भी आभारी हूँ, IPS Academy का भी आभारी हूँ कि आज जो है सराफ साहब की मेमोरी में बहुत 4-5 प्रोग्राम्स जो हैं ये सब नेशनल। आपने देखा ऐसे कंपटीशन के प्राइज़ में नाम सुने आपने? इंदौर का एक भी नहीं है, मध्य प्रदेश का एक भी नहीं है, कोई उड़ीसा का है, कोई कहाँ, मतलब आप सो देख लीजिए कि ये नेशनल लेवल की कंपटीशन है। आज भी जो है काफ़ी एंट्रीज जो है बाहर की आई हुई हैं। मतलब मैं ये तुलना नहीं कर रहा हूँ, जो अच्छा है उससे प्राइज़ मिलेगा। थैंक यू।
Thank you, sir, for giving information about the Indian Association of Physics Teachers and the exams they conduct. We are honored and pleased to have our guest of honor, Dr. Piyush Saxena, with us from RRCAT. Allow me to introduce you to Dr. Piyush Saxena in brief. He is a scientist H at RRCAT, the Department of Atomic Energy, and he belongs to Indore only. He completed his bachelor degree in electronics engineering from Ujjain in 1988 and Master of Science in Instrumentation from ISC Bangalore. He joined RRCAT in 1989 and for the last 33 years has been working on control, instrumentation, and system development for lasers and particle accelerators at the Laser Electronic Division. At present, he is the head of Laser Electronic Division and Project Coordination Cell at RRCAT. He served as Secretary Indian Laser Association and he is a Joint Secretary in Vigyan Bharati presently. He has about 75 research papers in conferences and journals. The Department of Atomic Energy was awarded 7 times during his career with a Group Achievement Award. He also has 1 Indian and 1 Chinese patent on referrer technology developed at RRCAT. Now I request Dr. Piyush Saxena, sir, to address the gathering. Please, sir.
Good afternoon and a warm welcome. Good afternoon and a warm welcome. Respected VC Madam Dr. Renu Jain is not here. My welcome to her also. Respected Dr. Anant Krishnan, Dr. Jiten Tripathi, the dignitaries from IAPT, professors and students. Good afternoon. First of all, I would like to acknowledge thanks to the organizers, IPSA Science Exhibitions, for giving me the opportunity to interact with you at this particular function. Science exhibitions like this are not new, but in this particular science show and exhibition, we exhibit the models and learn the science or learn the physics, chemistry and other parts of the science like mathematics and each and everything. So if you have seen the if you will see the exhibition, it is the inauguration of the exhibition, you will see different models on which you can learn the technologies also. You may see the models on solar cells and the different types of electronics models also in this exhibition, which are new technologies. As far as the physics is concerned, physics is the father of new technologies. In Department of Atomic Energy, we pursue the technologies related to the nuclear science, nuclear reactors, lasers, particle accelerators, and many more subjects like synchrotron radiation sources and all other things. We have different radiation sources. Radiation sources are limited because now the requirement of radiation sources are in the hospitals basically for the cancer treatment, and for research work very less or very limited radiation sources are available now. Previously we gave it to the universities for the research work and all those things, but still we are giving the radiation sources mainly to the hospitals for treatment of cancer, like the cesium source, iodine source, and many more other sources also we give. At RRCAT, we are having the two technologies of the radiations. One is the lasers, another is the particle accelerators. Laser is a tool by which you can do many things. We can do the cutting of the steel sheets up to 30 mm thick. That too at a place where we cannot go. Means if it is a radiation hardened environment, the laser can go there, we cannot go there. So that is the one major field in which RRCAT is involved. The maintenance of nuclear power plants. All the nuclear power plants needs maintenance by cutting the steel sheets or the pipes which are radiation hardened. So in that case, lasers are having a big use. As far as the particle accelerators are concerned, particle accelerators are the source of X-ray and other radiations which are used for spectroscopy, for and many other things like if you want to see the chemical composition of a drug, you can use. For protein crystallography, we can use the synchrotron radiation source. So all these sources are available at RRCAT. Students visit RRCAT at Science Day, means it is the last day of the February. We celebrate the Science Day, and students from IPS also visit the RRCAT laboratories. I invite you all for visiting the laboratory. Other than that, we have set up a light exploratorium also, in which all the students can come there and do the experiments related to the light that is like reflection, refraction, and all the other interference pattern generation, how the laser light is generated. Today I also have seen the experiment of synchronization by that with the pendulum. The laser also works on the same principle. When all the photons of the same frequency comes out in the same phase, it becomes the laser. Otherwise, it is a white light. So that is how the power of synchronization comes as the laser and a tool of new generation. I have also listened and learned about Professor Babulal Saraf and his science teaching model a lot today. The informative models touches the learning skills of the students directly. And the science show was also excellent. Sir, thanks. I'm thankful to you for such science show. Even we exhibit all the science models at RRCAT with the Lorentz force and the light experiments and other, of course, also the momentum conservation. But this particular science show was excellent. For the students, I would like to say that +1 and +2 books for the physics, NCERT physics books. These are like the Bible, Quran, or the Ramcharitmanas for you. And every chapter in that book has one technology. You can earn crores and crores of rupees if you learn by one particular topic of either it is thermodynamics, either it is electricity, either it is nuclear science, or the light sciences, or any other thing. Means if you make a goal that you expertise one of the topic from that, pursue your dream in that particular thing. Time management is of course important. You just go through your bachelor classes and then you go for the technologies. Yeah. Get time to improve your knowledge in that particular subject and you will be the leader of that topic. Of course, with the technologies, many changes will come. So, embrace the changes. Build resilience in that particular topic. And for all that, your education is important. So, you use your whole time for this education. Learn, apply, and earn. Learn, apply, and earn. That is my best wishes to all of you. Thank you. Thank you.
Thank you, Saxena sir. It's true, physics is the father of new technology. Thanks for giving us valuable information of the work done at RRCAT, especially giving radiations for the medical use. And I agree, each book of NCERT is library of knowledge. I'm really thankful to Dr. Piyush Saxena sir for coming here and giving his valuable time to us. Now it's last program of this session of the unveiling of the checks. Now I request Dr. Pradeep Joshi sir, Dr. Piyush Saxena ji, Dr. Anant Krishnan ji, Dr. S.K. Joshi ji, and Dr. Jiten Tripathi to unveil the checks. The first prize for the science exhibition is rupees 21,000. And the second prize is 11,000. And the third prize is 5,100 rupees. Thank you, sir. Thank you. Now I call upon Dr. B. Exhibitors, thank you, sir. Exhibitors are the lifeline of science exhibitions. They bring their innovative ideas to life, showcasing their creativity and scientific acumen. Their exhibits, often solving real-world problems, inspire peers and visitors, triggering a ripple effect of scientific curiosity and innovation. By bridging the gap between the theory and practice, they make science more accessible and exciting, inspiring future generations of scientists, researchers, and innovators. Our science exhibition will be immediately after the lunch. So today, on behalf of Institute of Science and Research, IPS Academy, Indore, I welcome students to demonstrate their original ideas and joyful attitudes towards science. Once again, my heartfelt welcome to all the participants from all over the country. Now I request Dr. Deepi Jain for the vote of thanks. After vote of thanks, there will be a photo session. So please be seated on your chair only. Please. Thank you.
Thank you, Dr. Usha Singh, ma'am. Very good afternoon to all members present here. On behalf of Department of Physics, ISR IPS Academy, I extend my heartfelt thanks to each and everyone for gracing their presence in this National Science Show and Science Exhibition. It has been an enlightening and inspiring event. My heartfelt thanks to our guest of honor, Dr. Piyush Saxena, sir. We appreciate your time and expertise in guiding our participant towards excellence. Today, we are honored to have Dr. Anant Krishnan, sir, among us, who not only graces us as a distinguished judge, but also captivated us with a fascinating science show. Your commitment to the field of science have been instrumental in shaping the success of today's event. A special note of thanks to Dr. S.K. Joshi, sir, who will be our esteemed judge for this science exhibition. Your meticulous evaluation and constructive feedback will undoubtedly contribute to all success of the exhibition. My special thanks to Dr. P.K. Dubey, sir, EC member IAPT, for supporting us always with open heart. Thank you, sir. We are thankful to Dr. B.D. Srivastava, sir, President IAPT RC9, for continuously motivating us. Our special thanks to IAPT RC9 for showing faith in us and providing financial support for this event. I would like to thank our principal ma'am, Dr. Premlata Gupta. You have been constant support and you gave us lot of encouragement. I extend my thanks to Dr. Jitendra Tripathi, sir, Head of Department of Physics and convener of this event. We are thankful to you, sir, for creating wonderful opportunity to organize this wonderful event. To all the participants, teacher, coordinator, and each member of ISR who worked tirelessly to bring the science exhibition to life, we extend our deepest appreciation. Last but not the least, a big thank you to the students, participants, and guests who have been graced us with their presence. Your interest in the world of science inspire us to continue fostering a love for learning and discovery. Once again, thank you to everyone who has been a part of this National Science Exhibition. Thank you and enjoy the rest of the program. Now, I request all the participants and guests to join us for the lunch after the photograph. Thank you.